So this is the third video in my series on using trigonometry with right angled triangles. So in this example, we've got these two triangles. We're told that ACB, so this triangle here, is a right angle, identified by this sign here. And in part one, we've been asked to show that this is also a right angled triangle, A to D to C. So if it is a right angled triangle, then we know that Pythagoras' theorem will apply. So if we sketch this triangle, if Pythagoras' theorem applies, then the area of a square on this side, well, this length is 126. So the area of a square will be 126 squared. And then we'll add this area to the area of a square on the base of a triangle. And we're told that this length is 120, so the area on this side of a square will be 120 squared. And we know using Pythagoras' theorem that these two areas on the shorter two sides should, if it's a right angled triangle, equal the area of a square on the hypotenuse side. And this length we're told is 174. And this area will be 174 squared. So if it is a right angled triangle, 120 squared plus 126 squared will equal 174 squared. Then we can work out both sides using a calculator. So we've got 14,400 plus 15,876 should equal 30,276. Well, we can work these two out, and we do get 30,276. So this is a right angled triangle, which we've proven. I'll show that with this symbol here. Okay. So for part two, now we've been asked to calculate the area of a quadrilateral ABCD, which is this quadrilateral shape here. And you can see this is made up of two triangles. The easiest way of working out this total area is to work out the area of triangle ADC and then add this to the area of triangle ABC. And we can work out the area of this triangle as 1/2 of the base times the height. So this would be 1/2 of 120 multiplied by 126. And this gives us 7,560 meters squared. But now we need to work out the area of triangle ABC. So if I sketch this out separately, we can't work out the area of this triangle until we know the base A to B. And we can work out this base using trigonometry. So if we label the sides, we know A to B is opposite the angle, so we'll call this the opposite length. And the 126 runs adjacent from the known angle to the right angle. So this will be the adjacent. And if we write down SOHCAHTOA, well, we have the adjacent, we want the opposite, so we're going to use tan. So the tan of the angle 48 will equal the opposite length, which we're trying to find, over the adjacent length, 126. So now to work out the opposite, we'll multiply both sides by 126. Because can you see this division and multiplication will cancel? So then 126 multiplied by the tan of 48 will give us the opposite length. And this works out at approximately 140. So if I label this on our diagram, 140, now we can work out the area of this triangle. This will be 1/2 times the base times the perpendicular height. And this gives us 8,820 meters squared. I should have said this is in meters, not centimeters. Okay, so then the total area will be the sum of the two triangles. So 8,820 plus the 7,560, which is 16,380 meters squared. Okay. Well, thanks very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.